Hey everyone! Welcome back to AI Code Hub, where we simplify AI and machine learning for you. If you're new here, make sure to subscribe and hit the bell icon to stay updated. Today, we're diving into an exciting machine learning project, predicting house prices using linear regression. This is a perfect beginner-friendly project to help you understand how ML models work step by step. So let's get started. Step 1. Importing libraries and dataset. First, let's start by importing the necessary libraries and loading our dataset. We'll be using the famous Boston housing dataset from scikit-learn. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import seaborn as sns from sklearn. Model selection import train test. Split from sklearn linear model import. Linear regression from sklearn metrics import mean. Squared error R2 score from sklearn.datasets. Import load Boston. Load dataset. Load Boston. df Gabris PD data frame dataset data columns owner dataset.feature.names. df price migate dataset.target. Display the first few rows df.head. Step 2. Data exploration and preprocessing. Before building our model, let's explore the dataset to understand the correlations and clean the data. Check for missing values, df.isnl.sum, data visualization, sns.pairplotdf, comma diagkind equals kdplt.show. Visualizing data helps us see relationships between features. For instance, the number of rooms seems to have a strong correlation with house prices. Step 3. Splitting data and building the model. Now, let's split our data into training and testing sets and train our linear regression model. Define features and target variable x equals df drop price axis equals 1y equals df price split into training and test sets. X train x test, y train y test. Trained test my sun split equals x, I test mock size equals 0.2, random state equals 42. Train the model equals linear regression. Model.fit x train y train. Let's check its accuracy. Step 4. Model evaluation. To evaluate our model, we'll use the R-squared score and mean squared error, MSE. Predictions y pred, idi yadword model, predict yadwx test, model performance MSE, reb1 mean squared error, y test, y pred. R2, reb1 R2 score, y test, y pred. Print f mean squared. Error, MSE, print FR2 score, R2. A higher R2 score means our model explains the data well. If needed, we can improve the model by feature engineering or using different algorithms. Step 5. Visualizing predictions. Finally, let's visualize how well our model predicts house prices. Polity scatter, y test, y psi, polity.x label, actual prices. Polity y label, predicted prices. Polite title, actual versus predicted house prices. Polite show. As we can see, our model performs quite well in predicting house prices. That's a wrap for today's tutorial on house price prediction using linear regression. I hope you found it helpful. If you enjoyed this tutorial, don't forget to like, comment, and subscribe. Let me know in the comments what project you want to see next. Hit the bell icon so you don't miss our upcoming AI and ML tutorials. See you in the next video. Happy coding!